Good morning, students. How are you all? I hope you are all doing good and studying really very hard. Today we will solve another problem from book Irodo, chapter Kinematics, and the question number is 18, 1.18. Let's read this question. A point travels along x-axis with velocity whose projection vx is presented as a function of time by plot. Okay, you will observe that in this book the language used is a little bit different than what given in the book written by Indian authors. Like, so here questioner is just saying that a particle is moving on x-axis and its velocity as a function of time is plotted here. The graph of velocity versus time is given, is nothing more. Assuming that coordinate of the point is x is equal to 0 at moment t is equal to 0, that means particle is at origin. They must have said particle is at origin. The language is like this only. At t is equal to 0, particle is at x is equal to 0. That is, and particle is moving on x-axis. Now we have to draw acceleration versus time graph. They represent acceleration as w. We will use a and we will use both so that there will be no confusion. There its x coordinate means its position as a function of time, and we have to plot distance versus time. Okay, so before we move, we must at least remember some concept that slope of a velocity versus time graph. What does it represent? Slope of velocity versus time graph. If I write slope will be dv by dt at any point, dv by dt, and this is acceleration. So we must at least remember that the slope of velocity time graph gives acceleration. So let's start plotting acceleration versus time graph. Let me draw here. This is suppose acceleration and this is time. Let me write all the time here. 1, 2, 3. You will learn a lot because I will also try to explain you the theory portion in between. So you will it will help you in revising also, right? Okay, so as we know that a straight line has a constant slope at every point on it, right? So from 0 to 1 second we are seeing a straight line. Actually we are observing that this graph is made up of different straight segments. So like 0 to 1 slope is constant, that means acceleration is constant. As we can see, slope is positive, obviously that means acceleration is positive. So from 0 to 1 we are observing that acceleration, that slope is how much? This length. Oh, let me use another pen. This this or this one is good. This length divided by this length. So tan theta will be 1 divided by 1. So at from 0 to 1 acceleration is a plus 1 meter per second square. Fine. Let me just scroll it a little bit. Now this remains constant as the graph is straight line. Now after that we can see slope has become 0. Slope has become 0. That means acceleration has become 0. So from 1 to 3, acceleration has become 0. Now from 3 to 6, again we are seeing a straight line but with a negative slope. So what is the slope here? Slope is actually, take this triangle, tan theta at least for magnitude, this upon this is also I think 3 upon 3. So it is 1 meter per second, but at least actually minus 1, slope is minus 1. So I will write like this, from 3 to from 3 to 6. So this is what we got here. Okay, just a minute, students. Okay, fine. Minus 1 meter per second square. Now After that we see again straight line is such that slope is positive, and slope will be equal to this divided by this, and this is 2, this is 1. I will say the slope is plus 2, and again the acceleration from 6 to 7 has become plus 2, so this is 1 and this is okay, fine. So this is like this, and if I extend this, then I will get here 2 meter per second square, and the extension here at this point. Let me extend this also like this. So I think you have got. Now after that again, if we see, uh, slope has become 0, velocity has become 0. So yes, graph will like. So all this which I have drawn with this orange pen is the graph of acceleration versus time, and I hope you have understood it very well. Now, how do we plot position versus time graph? So you must remember some concept which I am going to tell you. Now this is going. You can make a short notes also. When acceleration is positive, if acceleration, let me write with another pen. If acceleration is constant, firstly constant, then you must know that velocity versus time graph will always be a straight line. Will be a straight line. You know that, and we have already used this concept. That's why this graph is a straight line. Acceleration is constant everywhere. That's why graph was the combination of line segment. And when acceleration is constant, then you must also know that position time graph or displacement time graph, displacement time graph or position time graph will be a parabola, will be parabolic. Now you must know that parabolic. So if you have problem in graphs, then you can also refer to my video lectures which I have uploaded. You can go in playlist and you can find in 1D motion graphs. Yes, you will be able to draw all these graphs very easily. Now, when we draw position time graph or displacement time graph, we know that displacement is final position minus initial position, and if initial position is 0, then displacement and position time graph is same, right? Displacement and position time graph will be same. So as we know that in this question also, particle has started from t is equal to 0, from x is equal to 0 only. So initial position was x is equal to 0, so displacement and the position graph will be same. Also, most important, this was not what I wanted you to write in your notes, but yes, it is it will be used. Yes. Now what I want to say, when we will plot xt graph, then you must remember that if a is positive, then graphs open upwards, graph opens upward, and if a is negative, then graphs open downwards. You must know that, downwards. Like if I draw this for you, if this is position versus time graph, and if acceleration is positive, then graph will be like this, and acceleration positive, that means d square x by dt square is positive. And if you know maxima and minima, then yes, condition for minima is this only, like d square x by dt square. You must remember this. If double differentiation is positive, then xt versus graph, then the graph will be, we will open upward. And similarly, you must also remember that if graph opens downward, then it means d square x by dt square is negative, or acceleration is negative. Double differentiation of position is what? Second derivative of the position is what? Acceleration. So you have to remember this. And now we can approach to the graph. I will use this only. Okay. So again, I have to, I think, you note down all this thing. I will delete some part. Okay, dear friends, so let's start drawing this graph. So we know that particle has started from origin. So at t is equal to 0, particle is at origin. So I will start a graph from here. Okay. Now before we start, and like obviously when we will draw this graph, you must remember few points, few important points, so that you do not make graph wrong. Like obviously when we will draw graph, we will draw this graph in parts, right? Like from 0 to 1, and then 1 to 2, and like this. So before we start, we will check slope, because we know that position slope of a position time graph gives velocity, right? So we need to check slope at every step, at initial point also and the final point of this part also. And after that we will check if acceleration is positive or negative, and if acceleration is positive, we know that what we need to do, the graph will open upwards, we know that. So now as we can see, at t is equal to 0, velocity is 0, that means slope of position time graph is also 0. So I will start with zero slope. And yes, while drawing the graph, you may make some mistake and it will become difficult to draw that graph on scale, but okay, we will try. So we will start with zero slope, right? First thing is this zero slope, like this. So I am not taking it much above, like this. Okay. Now, as we know that the now slope has become zero, slope has become zero. Sorry, that means here that means acceleration has become zero, or we can say velocity has become constant, right? Velocity has become constant. Now, because velocity has become constant, slope will become constant. That means now from 1 to 2, this line will continue. This line will continue. So let me draw this graph. Till like so, this graph you can assume that slope did not change. It is continuous. Slope is continuous, right? Slope did not change. Now this is 3. We have reached to 3. Now after 3, you can see the slope has become negative. That is, acceleration has become negative. This part is parabolic. You must say, because acceleration is positive, this part is parabolic. This is straight line. I will write in the end in with other pen. Okay, fine. 3 to 6. We can see 3 to 6 for 3 second to 6 second. We know that continuously velocity is decreasing, acceleration is negative. That means graph will open downward. But before we must check that at t is equal to 4, velocity has become 0. That means slope of position time graph must become 0 at this point. So let me draw this with a solid line like this, and for all this thing I will use this. Now we know that the slope must become 0 at t is equal to 4, so I will do that like this. That is the difficult part actually, how to draw this graph. Now one more thing, if you observe that we you know that velocity, the area under velocity time graph gives you a displacement. So if you see from 3 to 5, from 3 to 5, 3 to 5 only, whatever area is upward is also equal to downward, right? If you can understand this, that if this is zero point 0.5, then this is minus zero point 0.5, right? This will cancel out. So whatever I am shading this portion, this both have equal area, and we know that area under the velocity time graph gives displacement. So from 3 to 5 second, net displacement will be 0. So from 3 to net displacement means final position must be same. So this is 3 and this is going to be 5. Let me draw with a straight line. This is 5. Okay, I have changed pen. Right, this is it. So graph must come at this point like this. Yes, because We know that from 3 to 5 displacement is same, so displacement is 0, so position must be same at 3 and 5. Now after that, still from 5 to 6, we know that it has continuous, still is it decelerating, so graph will continue to open downward, graph will continue to open downward. Now it is going to be difficult. I'm trying to decrease. Okay, man, this is, so still I managed to make it parabolic. Fine, okay. Now after that, you can see the slope has increased, and now from before I start plotting from 6 to 7, 6 second to 7 second, I will see at 7 second what is the slope. So I am seeing that at 7 second velocity has become 0, that means slope must become 0. So what I will do, you know, that I will make it parabolic like this, and I will make slope 0, right? So this is how the graph is, and after that it stays at rest, so graph's position will not change. I hope, student, you got it. So this part is parabola, this part is a line. Again, this part is here, from here to here acceleration is negative, and this is parabola. From here to here, this is again parabola, but we know that acceleration is positive, that's why graph opens upward. Here acceleration is positive, that's why graph opens upward, right? So this is how you plot graph, and you must practice this. Now this is also displacement time graph. Now let me draw distance time graph. Okay, we have not marked the position. Yes, if you want, you can mark position also. As we can see, displacement is equal to the area under the velocity time graph. So from 1 to this, from 0 to 1 second, what is the displacement? It is 0.5. It is 0.5. Here displacement is 0.5. Now from 1 to 3, if I say this, from 1 to 3 displacement is 2 meter. Again this is zero point 0.5. Now this is also minus zero point 0.5, because area is downward, velocity is negative, in this velocity is negative, that's why displacement is negative. Now again you have to take this whole area actually, right? Now this whole area will be from let me say 4 to 7 second. If I see, the area will be 4 to 7 second, the area will be half into base 3, area will be 3 meter, but actually minus 3. I must write minus 3, right? For 3 second it is minus 3. Now I can mark all this. As we can see, from 0 to 4 second, velocity is always positive, so displacement was increasing only. So at 1 second, it is zero point 0.5, right? After at 3 second, we saw this x as um, how much? 0.5, 2.5. So x is equal to 2.5 meter. Then again at t is equal to 4 second, zero point 0.5 meter is added, so this is going to be 3 meter. Now after that, we know that t is equal to 3 to 5, it will be at same position. Now at 6, at 6 second, or let me just this whole is 3. Okay, from here to here, this is minus 3. So from here it has come down to here, so this is minus 3. And if you want, you can also find what is the displacement till 6 second, but I'm not interested. I think yes. I hope that you can draw this. uh, this is going to be 1, maybe. I think this is going to be 1. This is what I see. Yes, yes, it is going to be 1. So this is how you can plot, right? Now distance time graph. Here you can see displacement is decreasing. This is same as displacement, right? So displacement has increased from 0 to 4 second as velocity was positive. So if I draw a straight line So what I am observing is that from t is equal to 0 to t is equal to 4, a particle was moving in this direction continuously, right? And after that, particle took a turn, and it has come to the same point x is equal to 0 at t is equal to 7 seconds. This is what happened. So from t is equal to 0, distance and displacement is same because particle was continuously moving in same direction, right? But from t is equal to 4 onwards, we can see that displacement is decreasing, right? Because displacement is the distance between the initial and final position. At t is equal to 7 second, displacement has decreased to 0. But did distance traveled also becomes 0? No, distance always increases. So it total distance traveled is actually, this is how much? This is 3. This is 3 meter, and this is also 3 meter. So total distance traveled is 6. So to draw distance time graph, you must do like this. We know that distance always increases. So about this line, whatever happened as downward, or let me say the graph of distance will be mirror image. Mirror image. Let me draw like this. I will draw exactly. I will try to draw it as mirror image, but obviously I won't be able to draw on a scale like this, like this. I hope student you got it how to draw graph. And yes, total distance will be, here it will be 6, it will be 6 meter. So graph of the distance versus time graph will be like this is. Okay students, I hope you understood how to draw graph. Yes, obviously you have to give time, and if you uh, have doubt and you want to understand how to draw graph, then you can go to playlist and watch all the videos I have uploaded before. Okay, students, if you like this video, if you learn something from this video, do like and give comments. And if you have not subscribed to my channel, do subscribe, and also don't forget to press bell icon, because you will get instant notification whenever I will upload video. And yes, I will continue to upload all the questions of Irodo. Okay, students, I hope you learned a lot. Okay, happy learning, students.